Okay, practice number 2 coming up. This will be another example of a goodness of fit test. Okay, so a lot of goodness of fit tests are like practice number 1, where you assume there's a uniform distribution. The data is equally spread throughout your categories. But a goodness of fit test isn't limited to that. Let's take a look at practice number 2. It says a study on American households found the percentages for the number of television sets in the home. Okay, so this is looking at this is a sample that spans the entire U.S. Okay, so they found the number of TVs in the home and the percentages, right, that go with each. So 0 TVs in the home, 3%. 3% of homes in the entire U.S. don't have a TV at all. 1 TV in the house, 16%. 2 TVs in the house, 55%. 3 or more, the 3 plus, 3 or more TVs in the house, 26%. Okay, so we've got data for the entire US there. If you look at the top of the next page, it says a random sample of 500 San Diego households gave these percentages. So we've got the same number of TVs, but obviously the percentages change a little bit for San Diego. So 0 TVs in the house, only 1% of homes in San Diego, or at least from that sample. 1 TV in the house, 23%. 2 TVs in the house, 64%. 3 or more TVs, 12%. Okay, from San Diego. So what's the question here? At alpha equals 0.01, does it appear that San Diego households have a different distribution of TVs in the home compared to the larger American population? We are going to compare the percentages from San Diego to the percentages from the larger United States, the larger American population. And we're just asking, do we have enough evidence that San Diego has a different distribution? And just notice how broad that statement is. We're not saying San Diego has more TVs or more homes with 2 TVs in the house, or less TVs with a less percentage of 0 TVs. We're just saying, is the distribution different for San Diego compared to the larger American population? Okay, let's dive into it. What's our null hypothesis? The null, of course, is that there's no difference. And any way you want to phrase that will do. So, looks like I said something else here at the beginning before I got into the steps, and I forgot about that. If you're wondering, okay, so I know we're going to have to think observed and expected. Which is which? So we've got these 2 populations, right? We've got the American data and we've got the San Diego data. So the way we're going to go with this, San Diego is the observed, right? That was our sample. A sample of 500 came from San Diego. So that's our observed data. That's the data we collected. So that means the American population is the expected. And we're kind of thinking, when we gather our data for San Diego, we expect it to match the larger American population. Okay. Here's another way of saying it. San Diego is a small portion of the United States, right? We will always take the larger population as the expected. So what we do is we look at data from a smaller portion and we expect it to match the larger population. Okay. So we say the American population is expected, and then San Diego, a small piece of the American population. That's where we did our sample. That's our observed. Okay, good. Glad we got that out of the way. Now, what about our null hypothesis? Okay, so we assume that the 2 are the same. Okay, so I wrote H0, the distribution of San Diego TVs in the house is the same as that for all Americans. There's many different ways you could say this. Just be sure that it's clear that you're saying the larger American population for TVs in the home, percentages of TVs in the home, is the same as the San Diego population. Okay, the keyword is there, the same. So then what's our alternative hypothesis? Well, we can change the word same to different, and we'll be fine, or different than, right? The distribution of San Diego TVs in the house is different than that for all Americans. Same as, right? Those are our two phrases, same as, different than, right? You could also say distribution of San Diego TVs in the house is not the same as that for all Americans. That would be fine too. Not the same, different, it all works. Okay, but you got to write it out in words. Very nice, very nice. So let's take a look at our test statistic, and now we know what's observed and expected. Here, we don't, we can really just, oh, it looks like I'm going to the next page. We can really just start to fill in our table, and I'll show you one line at a time. Our categories, you see there at the top. The categories are 0 TVs, 1 TV, 2 TVs, and 3 or more TVs. Okay, so then the observed is San Diego, right? That's our sample. That's the smaller group within the larger group. So the observed, we're just going to look right at that table from San Diego, right? And it was 1%, 23%, 64%, 12%. Now here's something we got to be really careful about, and it's not clear why this is true. At first, when you fill these in, just use the whole numbers, 1, 23, 64, 12. Do not convert them to decimals, like 0.01, 0.23. Don't do that. Just use 1, 23, 64, 12. If you convert them to decimals, then you'd have to be really careful at a later step, and there's no reason to have to do that to yourself. It's much simpler and straightforward if you just use the whole numbers here. Okay, then the expected, right? So that is the larger American population. So we fill in those percentages, right? 3, 16, 55, and 26. And what we're looking for, is there a difference? Is there a statistically significant difference between these values? And just at a glance, yeah, I mean, there's some, right, 1 to 3, that it seems like there's some pretty big jumps, in each one of them. But who knows? Sometimes we don't. It's not so obvious. Okay, so what are we going to do now? We're going to do our calculation. O minus E squared over E. So we'll do that for each column, and you can see that I went ahead and went with the fractions again. You can use decimals at this point if you like. I recommend 4 decimal places. Honestly, I find the fractions are just less work, especially if you've got a calculator that can convert, and any scientific calculator will be able to do that. So for instance, if we go with like the 6455, 64 minus 55 squared over 55, right? It gives me this number, but then I can convert F to D, fraction to decimal, boom. And that's just going to be easier to add these numbers up a little bit later. 81 over 55 compared to 1.4727, right? Okay, anyway, make sure you can reproduce all of these numbers. Then what are we going to do? Well, we're going to add them all up. That's how we do our summation, right? So chi-square, when you add those, now you do want to use a decimal, and I like to round to 2 places. I got 13.41 for the test statistic here. Okay. Okay. We're done with step number 2. Now we want to calculate our p-value. So you're going to go to your chi-square calculator in StatCrunch. Okay. You're going to put a greater than. Remember, it's always greater than 13.41. Degrees of freedom. What are the degrees of freedom this time? Well, you notice we've got 4 categories. And so we subtract 1, so degrees of freedom is 3. Okay. So hopefully you guys are able to reproduce that p-value 0.0038 with that chi-square value and those degrees of freedom. Okay. And then we'll go on, and I've already got this filled out. A p-value 0.0038. We had our alpha at 0.01, which is a small alpha, right? But still, that p-value is very tiny, much smaller than our alpha. So we put a less than there. And we're wrapping this up pretty fast. If our p-value is smaller, alpha is bigger. What does that mean? In step 5, we reject the null hypothesis. Our sample data did make it into that shaded region inside that 0.01 for alpha if we were to draw it on that upper end. Okay, I won't draw it out for you, but we do make it into that top end in the shaded region. We reject the null hypothesis. Maybe an interpretation for this one is a good idea. When you reject, you do have enough evidence. There is enough evidence that the distribution of TVs in the home is different in San Diego compared to the larger American population. Again, you start with there is enough evidence, and then you're pretty much just repeating your alternative hypothesis. There is enough evidence that the distribution of TVs in the home is different in San Diego compared to the larger American population. Very nice, very nice. Okay, let's stop here, and in the next video, we'll talk about the test of independence.